we're going to find the area of the shaded region. So each circle has a radius of 2 inches. So this part here, we want to declare as being 2 inches. Well, that means the diameter is 4. So if we keep going across here, we're going to realize that we have 4 for a diameter, 4, 4, and we can figure out that this is 12 inches. We want to leave our answer in terms of pi, so basically we're going to find the area of the square with a side of 12, and we're going to subtract each of the smaller circles there. So we take the area of the square and we subtract, actually we have 9 times the area of one circle. All right, so the area of the square is going to be 12 squared, which is 144, and we're going to subtract from that 9 times the area of one circle. So one circle is going to be pi r squared, which is 4 pi. So one of the things we're testing you here is to see if you're figuring out how to leave answers in terms of pi. So we have this number, and then we want to have inches squared because it's an area problem. For problem 21, find the probability. So basically we're going to take our answer that we just found out. So 144 minus 36 pi becomes the numerator in this problem. And we're going to divide by the area of the entire figure. So that's 144. So probability, really the hardest part is finding the area of the shaded. Then we just have to divide by the area of the whole. So this comes out to approximately 0.215. Moving on to the next one, 23. Probability again. Randomly chosen point inside the equilateral is not inside the circle. So inside, but not inside the triangle, but not inside the circle. So that's the shaded region. We got the radius shown as 6. So here we are going to simply take the area of the equilateral triangle minus the area of the circle. So let's just do what's easy first. The area of the circle we can clearly see is 36 pi. Now we have a formula for the area of the equilateral triangle, and that would be side squared root 3 over 4. Well, we need to know a side. I don't like working over here, so I'm going to work down here, but realize this right here, sorry about that, is also 6. And if we set up a triangle here, we can see that this is going to become a 30 here and a 60 here. 30 because of the bisected equilateral triangle vertex there. So if this is 6, then we can clearly see that this is going to be 6 root 3. So this side here is going to be 12 times the square root of 3. So the area of the triangle is going to be 12 root 3 as the s value squared times the square root of 3 over 4. So to complete this calculation, we do 12 squared, which is 144. Then we multiply by 3 because root 3 squared is actually just 3. We still have the root 3 from the formula divided by 4. And I personally like to simplify these right off the bat. We get ourselves a 1 and a 36. So we find out that the area of the equilateral triangle is 108 times the square root of 3. So to find the probability, we're going to take the area of the shaded, which again is going to be the triangle, 108 root 3, minus the area of the circle, which will be 36 pi. And we're going to divide by the entire figure, which is the area of the triangle, 108 root 3. Be very careful when you put this in your calculator with parentheses, with making sure on the Inspire when you enter, you're actually doing what you want, or the calculator is doing what you asked. It will always do what you ask. It will not fold your laundry, it will not put away the dishes, but it will always do exactly what you ask. And sometimes you actually ask it the wrong thing by forgetting parentheses. Number 24, find the probability that a point chosen at random inside the circle is also inside the hexagon. So we got to read these very carefully. We're actually just looking inside the hexagon for what we're defining as successes here. So to find the area of the hexagon, you can take one of two methods, doesn't matter, or the hexon. There we go, hexagon. The area of the hexagon is equal to 1/2 apothem times perimeter, or you can think of it again as 6 times s squared root 3 over 4. Either way, they both work for the regular hexagon. The key is here, we have a radius of 6. So this is 6, And when we drop down here, wow, when we drop down, we're going to have ourselves, again, the 30, 60, 90. But in the hexagon, it's different. This is the 60, whereas up here, that was a 30. So opposite the 30 is going to lead us to our side. So what we have here is actually 3 root 3, using the special 30, 60, 90 here. This is 3, and we know that the side is going to be 6 because these are all equilateral triangles in there. All right, so if we're going to use 1/2 apothem times perimeter, I'm going to do that because the majority of my students said that's what they were doing. 1/2, we would do apothem, which is 3 root 3, and then we would multiply by the perimeter, which is 36, because there's 6 sides of 6. Okay, so however you find it, even if you use this formula, you are going to get an area of the regular hexagon to come out to 54 root 3. 1/2 of 36, if you do it this way, 1/2 of 36 is 18. 18 times 3 is 54. All right, so to find the probability, we just found our numerator, which is 54 times the square root of 3, and the denominator is actually really simple because the whole figure is a circle radius of 6. So the area of that is pi r squared, which is 36 pi. And when we divide that, that comes out to 0.827. What is the probability of the regular hexagon area, randomly chosen point, be in the circle? 0.827. What is the probability of you loving math and enjoying this video? Right there. Yeah.